Hello everyone, my name is William Arnold and this is my video report for Lab 4 of Physics 2211 on oscillations. The fundamental principles covered in this experiment were the momentum and energy principles. The momentum principle was used to observe and explain the motion of an object attached to a spring and the ensuing forces that caused said motion. The energy principle was used to analyze the change in total energy and energy components of the spring mass system throughout its motion. The first part of this experiment was a video analysis of a spring and its motion in real life. Here is the setup for the video of the spring in tracker. The mass attached to the spring was dropped from rest. It then proceeded to both oscillate side to side and up and down during its course of motion. The position of the center of mass was tracked at each frame, providing position data points for both the x and y components of the mass attached to the spring during its course of motion. Here are the graphs of the position data points produced by tracker following the completion of the tracking of the object's motion. As shown by these two graphs, the object's motion followed an oscillating behavior in both the x and y direction. The second part of this experiment involved the production of a computational model to predict the object's position versus time and compare it to the observed data points. The model also produced a graph for the total energy and energy components of the mass spring system that will be discussed later in the report. Here are the initial conditions for the mass spring system. The mass of the object connected to the spring was 0.402 kilograms, and the initial position and velocity were obtained from the initial data points in tracker. Delta t was small and an integer of the frame rate of the video, found to be 1/210, and the spring constant was given to be 6.83. The relaxed length of the spring was also given to be 0.123 meters. This part of the code was used to analyze the net force acting on the object at a given time and to update the object's position and velocity using Newton's second law. Gravitational force and spring force were the only two forces acting on the object. Because the force was not constant, it also had to be updated at each time increment. This part of the code produced values for the energy principle. K represents the kinetic energy, UG represents the gravitational potential energy, US represents the spring potential energy, and E represents the total energy of the system. The system included the spring, the mass, and the earth, which is why all three of these values were included in the total energy formula. Here were the position versus time results obtained from the computer simulation. The blue line represents the modeled position versus time, while the red line represents the experimental data. As shown by the graph on the left, the model almost perfectly predicted the x position of the spring over the time interval. However, it was very inaccurate in predicting the y position over time. I believe this is due to the value of k, the spring constant. It was given as 6.83. However, my calculations found it to be 6.09 for this experiment. When I plugged in this value for k, the y position for the model was much closer to the actual values obtained. Did this experiment satisfy the energy principle? The answer is yes. As shown by this graph, the total energy of the system stayed at 0 for the entire time period. This is shown by the fact that delta E is 0 the entire time. As shown, any conversion from potential energy to kinetic energy, or vice versa, is conserved within the system, which is consistent with the energy principle. Here are the periods of oscillation that were found when analyzing the position versus time data in tracker. The period in the x direction was found to be 1.61 seconds, while the period in the y direction was found to be 1.52 seconds. I believe this slight difference is due to the fact that some forces, particularly the drag force, were neglected, and the elongated shape of the mass produced greater drag in the x direction than the y direction. This led to a longer period of oscillation in the x direction. That is the end of my video.